Hi dear all, welcome you all to the brilliant group of institution. Here we are discussing the integrated rate equation for zero order reaction from the chapter Chemical Kinetics. Dear all, we have a derivation for the integrated rate equation for a zero order reaction. Let's go for the derivation. Here we have to discuss some important concept, dear all. Here, integrated rate equation for zero order and first order reaction that we have to study in Chemical Kinetics chapter. So, integrated rate equation for zero order reaction, let me consider a reaction that is R. So, this is a reactant, okay, this is the reactant R which gives a product P. So, R is the reactant and P is the product, alright. Now, how we can write the rate of this reaction, dear all? Rate of a reaction, it is depends on either you can express in terms of reactant or in terms of product. Yes or no? Because how can you represent in terms of reactant? How much reactant consumed, right? How much reactant reacted with a time? Or you can say how much product formed in a reaction with respect to a time. Yes or no? So let me tell you the rate. Rate means speed of the reaction in terms of R. How can we represent it all? Minus dr by dt is equal to. Why minus? Minus sign indicate that, during a reaction, reactants are consuming, yes or no, and products are forming. So when you write in terms of reactant, we should use the symbol minus. If it is in terms of product, we have to use plus. Clear all of you? So minus dr by dt. Why dr? Dr means change in concentration of reactant with respect to time. So this is the speed, right? So rate of a reaction we can express by minus dr by dt is equal to, what is the rate equation? That is equal to k into r to the power 0. What is k here? Rate constant, alright? Rate constant into r to the power 0. What is r? Reactant, right? Reactant to the power 0. Why here the power is 0? Dear all of you, here we are dealing with a zero order reaction. What is zero order? Order means it is a sum of the powers, right? Sum of the powers of the concentration terms. So this is called rate equation. What is rate equation? Rate is equal to rate constant into reactant to the power the order. That order is 0 here. So the r to the power 0 can be placed. This is the rate equation for the zero order reaction. Now we can go for the derivation. Here we can write minus dr by dt is equal to k. Why? Because r to the power is equal, r to the power 0 is equal to 1, right? Any value to the power 0 is equal to 1. So r to the power 0 is equal to 1. So the RHS is just rate constant k. Now I'm just rearranging the system, all of you. I can write dr is equal to, let me bring this dt to the right side. So minus k into dt. Clear all of you? A small derivation. Now I'm going to integrate this equation. Dear all, integral of dr is equal to minus k. It's a constant. We can take it outside. So minus k into integral of dt. We have a general equation, dear all. Integral of dx is equal to x. Integral of dx is equal to x. So what is integral of dr? That is r. What is integral of dt? That is t. Yes or no? Let's see all of you. Integral of dr is equal to r. Even integral of dt is equal to t. So we can write that r is equal to, why r? This equation changes, all of you. Integral of dr becomes r equal to minus k. Integral of dt is t. After integration, you will get a constant c, that is called integral constant. All of you, integral constant. So we integrated the equation r equal to minus kt plus c. Next, this equation you can observe. Now after getting c, what is c is called here? Integral constant. After getting integral constant c, our duty to find out what is the value of c, integral constant. In order to calculate the value of c, let me consider two assumptions. What are they? When time equal to 0, when time equal to 0, what is that meaning? Time 0. Time 0 means we are starting a reaction. Yes or no? When we starting a chemical reaction, time is 0. Then at that moment, what you have? When you're starting a reaction, what do you have? Do you have product? No. When you're starting a reaction, we have only reactant, right? Initial concentration of reactant, that is represented by R naught. So dear all, at a time 0, what is the concentration of reactant? R naught, which means initial concentration. Please apply time equal to 0, R equal to R naught in this above equation. What becomes, dear all? This R becomes R naught minus KT. T is 0, right? So this term will be 0 is equal to C. So R, C value we got it. C is equal to R naught. That C is equal to R naught value we substituted in this equation. So R equal to, that's R here, minus KT, okay, plus what is the value of C found here? R naught. So all of you, after getting C, we have to find the value of C. In order to calculate the value of integral constant C, we are taking two assumptions. What are they? When time equal to 0, R equal to R naught. When we substituted in this equation, we are getting C, integral constant C is equal to R naught. That value we substituted here. So R equal to minus KT plus C is equal to what now? R naught. This is in the format of a straight line, dear all. C value we calculated, that we substituted. The C value substituted equation is in the format of what? It is in the format of a straight line. Y is equal to mx plus C. Dear all of you, this is in this equation is in the format of what? Y is equal to mx plus C. What is Y? Which means what is on Y axis? X axis, m is the slope of the line, and C is the Y intercept. All of you, let's draw the graph. They will ask you the questions related to the graphical representation. So dear all, let me take what is on Y and X axis, dear all. Y axis R, concentration of reactant R. X axis, what is that? Time. T is there. Now we can plot the graph. See, your slope is m, where slope is equal to minus k. Here slope is minus, dear all, so it should be a declined line. Then if you take the slope of the line, it will be minus k. Slope of the line will be minus k. So they will ask you the question, what is the slope of this zero order reaction, the graph between R and T, like that. Okay, for the theory exam, careful. Next, what is C is called here? Here C is called integral constant. Here in equation of straight line, C is called the y-intercept, which means this distance is called what? Y-intercept, that is R naught. Once again, all of you, as per this straight line equation, y-axis you have R, x-axis you have T, and slope of the line is minus k, and y-intercept is R naught. Hope you clear how to draw the graph. Yes? Next. Now we are making a simplification. Why we are deriving this equation? Why we are integrating this zero order reaction? In order to calculate the value of K. What is K? Rate constant. And also we have to calculate the value of T, half-life. I'll tell you later. First, so we got already R equal to minus KT plus R naught. Yes? Let me just rearrange. Let me take it KT left side, R to the right side. So what it become? KT is equal to R naught minus R. Then what is the expression for K? Then K is equal to R naught minus R by T. This is the equation for our numerical question. So what is the integrated rate equation for the rate constant K value for a zero order reaction? What is the equation? R naught minus R divided by T. That is the equation for rate constant K. Now I want to calculate what is the value of T half-life. What is the meaning of T half-life? Dear student, what do you mean by half-life? You consider, initially you have a system with 100 gram concentration. Okay, initially you have 100 gram concentration. Now, after some time, it becomes 50 gram. So what happened here? The initial amount is 100. It is reduced to its half, that is 50 gram. Yes or no? This time taken for the reduction of this or the consumption of this initial amount to its half of the amount is called half-life, T half. Okay, so what time taken for an object to reduce its half amount is called what? Half of the initial amount is called what? Half-life, or represented by T half. Okay, see, I'm going to calculate the half-life of a zero order reaction. I'm taking two again assumptions, dear all. When time equals to T half, when When time equal to t half, that means what? The initial amount reduced to half. Yes or no? So I can say R is equal to R naught by 2. Why, dear all? I told you initially you have 100 gram substance. How much time it will take to reduce into 50 gram? That is called half-life. So when time changes to half-life, what will be the concentration of reactant R? It becomes R naught by 2. R naught is what? Initial concentration. Its half will be there. Now let me substitute T equal to T half and R equal to R naught by 2 in this above equation. So what it becomes, dear all? K is equal to R naught minus, what is R become? R becomes R naught by 2, right? R naught by 2 and T becomes what? T half. See, this will be the equation. So K is equal to R naught minus, what is R now? R naught by 2 divided by, what is T now? T half. Clear all of you? Now let me just rearrange. I want to get the value of T half. I can write here, this is the equation we are going to rearrange. See all of you. This K is equal to this 2 R naught. Let me cross multiply. So this 2 R naught minus R naught divided by 2 into T half. That will be the new equation. After that, let me arrange K is equal to, what is 2 R naught minus R naught? That is equal to R naught, right? So R naught divided by 2 T half. Next, let me make the final equation, that is T half is equal to R naught divided by 2K. So this is the overall equations for zero order reaction. So dear all, in this session we are dealing with integrated rate equation for a zero order reaction. The main two equations you have to remember. What are they? Where K is equal to, rate constant is equal to what? R naught minus R the whole divided by T. Whereas what is the half-life of a zero order reaction? Half-life T half is equal to R naught divided by 2K. And do you remember the graph? Tell me which is on y-axis. Y-axis you have R. What is on x-axis? X-axis, that is a time. What is the slope of the line? Minus K. And what is the y-intercept? C, that is R naught. Hope you clear how to derive the integrated rate equation for a zero order reaction, especially to calculate what is rate constant K, what is the half-life and the graphical representation. Hope you clear, dear all, how to represent the zero order integrated rate equation. Thank you all. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.